The molecular formula of benzene is C6H6. So write down the structure of benzene. It will look like this. Okay, and in each carbon the hydrogen atom will attach. So this hydrogen atom. Okay, now check the valency of carbon. We know the valency of carbon is 4, but in the structure of benzene we will find the valency of each carbon is 3 here. So if we have to fulfill this requirement of valency 4, then we have to input a double bond in this position, alternative position. So this is the actual structure of benzene. So here if you look at this, you will get in each carbon there is 3 sigma bond. So if we take this carbon, so there is 1 sigma bond, and there is another sigma bond, and there is another sigma bond, and there is another pi bond. This is the pi bond. So the hybridization state of each carbon is sp2 as each carbon possesses 3 sigma bond, and we know the pi bond never participate in the hybridization state. So the hybridization is type of sp2. So if we look the actual case structure of benzene, it will look like this. So in hexagon, the each position define the position of carbon. Okay, so now put the unhybridized p orbital, so each carbon as unhybridized p orbital, and it is 2pz and it is 2pz orbital, we know. So three-dimensional structure will look like this. So this pi orbital, unhybridized p orbital, will form a case structure of benzene. Okay, so this is the structure of benzene. So the benzene has a special characteristics, and it is the delocalized pi-electron. So what does it mean? It means the pi-electron of benzene can delocalized within this structure. So this is the pi-electron of benzene. So we know there is 6 pi-electron of benzene in the structure. So why 6 pi-electron? Because there is 3 pi bond, and in each pi bond possesses 2 pi electron. So overall 3 pi bonds. So we will overall get 6 pi electron. So according to Haeckel's theory, which states that 4n plus 2 number should be a number of pi electron, and where the n will be integer number. So if we input 6 here, we will get 4n equal to 6 minus 2 and 4n equal to 4. So n equal to 1. So see, this is the integer number. That's why we can say that benzene is an aromatic compound. So what does it mean, aromaticity? Now see the delocalization of pi electron in benzene structure. So we write down the structure of benzene. This is the pi bond of benzene. Now this pi bond can shift in another position. Like this pi bond can shift there, then this pi bond can shift there, this pi bond can shift there. So then we will get an alternating structure of this, just like this. Okay, so the pi bond will be changed, the pi bond position will be changed. This pi bond will here, and another new pi bond is here, another new pi bond is here. So these two structures are equivalent, and this character or manner is called pi-electron delocalization. And this pi-electron delocalization is the special character of benzene which gives the benzene of credit of aromaticity. So when benzene has no substitute in their ring, so each position are equivalent, and you can name by this way. Like you can write this position 1, this position 2, 3, 4, 5, 6, and you can also write this position this way. Okay, fine. You can say this position 1, this position 2, and is 3, 4, 5, 6, and so on. Okay, so when benzene has no substitute in the ring, each position are equivalent. So numbering in benzene are all right. You can numbering is anywhere. But when a substitute group is attached in benzene, like okay, so think here is a substitute group and its name is A. So when the substitute group will attached in benzene, the position of benzene will not be same. So when the substitute will attach the ring, the number of the carbon must be 1 in where the substitute group is attached. Then other carbon you can named, okay, so you can name them by right way or left way. So think I'm numbering in right way, so just it is 2 and is 3, is 4, is 5 and is 6. So see, the 2 and the 6 position are equivalent. So why they are equivalent? Okay, so I am numbering in the right side. So if one number in the left side, see this position will be 2 and this position will be 6. That means 2 and 6 positions are equivalent. So 2 equivalent 6, and these 2 and 6 are called ortho position. Ortho position. Okay, now look at, then see this 3 and 5 position are equivalent. Why? Because if you counting in the left way, this 2 and this will 3 and this will 5. So 3 equivalent is 5 and 3 5 position are called meta position. Meta position. And there is a unique position which is just opposite of number 1, and this is the position 4. So this position 4 is called is called para position. Is called para position. And in the next lecture we will see what is ortho, para and meta directing group. Ortho, para and meta directing group. Stay tuned, thumbs up and subscribe.